Today we're going to talk about the real number system. Every number that you've dealt with so far in your math career have been real numbers. So we're going to talk about breaking those down and identifying those numbers to what they are. So we're going to think about this as a big umbrella at first. This is the real number system, and all the numbers we're going to talk about right now are going to be in the real number system. So we'll deal with real numbers first, and then we'll talk about what non-real numbers look like. So an irrational number is a number that cannot be written as a fraction. So think about someone that may act irrational. Something very small, like dropping a drink on the ground. They may completely flip out and start screaming and acting just irrational, like they have no sense. So they just kind of go on, and it doesn't really make any sense of what's happening. So in terms of a number, these are those numbers that are non-ending. Pi is an example, 3.1419, and it keeps going forever without a pattern. There's no pattern at all of what is happening. It's something that's non-repeating. Maybe you have a number like 2.4142, and then it starts going as 4, 3. There's nothing repeating. Yes, it looks like a pattern that's happening, but it's not repeating itself. It's not 414141, okay? So don't confuse this with something like 0.33333. That is actually a repeating decimal, and it can be written as a fraction. So we're looking for something that is irrational, doesn't have a pattern, doesn't make sense. It just goes on forever, and it cannot be turned into a fraction. Now, the next part of this is the rational numbers. So rational numbers is broken down into 3 parts. But a rational number is a number that can be written as a fraction. So we go from rational numbers as the big overall kind of umbrella down to the next level, which is an integer. So integers are whole numbers and their opposites, such as 1, -1, 2, -2, and this does include 0. So we'll put a note there. This does include 0. But 0 is very special. He can fit into a lot of places. Our next level is a whole number. These are counting numbers or natural numbers and 0. So when you learned how to count, these are those numbers where you did 1, 2, 3, 4, 5, but then it does include 0. There are no negative numbers in whole numbers. You can't have a whole of something if you have negative amounts. There's nothing tangible there. So whole numbers are always positive numbers, and it includes 0. The next level is natural numbers. Now, natural numbers are another name for counting numbers. So counting numbers, when you were little, you never started at 0, 1, 2, 3. When you learned to count, you started counting at 1, 2, 3, and so on. This does not include 0. So these are the very bottom level. So I'm going to show you kind of an umbrella you can think about as a real number system. We have integers, whole numbers, and then natural numbers. And then over to the side, we have those irrational numbers. These are all part of the real number system. So we have to think about what they mean. So here's a little bit better visual, kind of that you'll see more often. So this whole big black box is the real number system. And within the real number system, you have 2 separate areas. You have the irrational numbers, which cannot be written as fractions. Those are those non-ending numbers, those non-repeating patterns, something like pi or 0.267384. Those little ... means that something is continuing. There's something going on. We just don't know what it is. It's going on crazy. It could be a 2 next. It could be a 1. We're not really sure. The square root, we know that if we put in our calculator the square root button and we hit 2, that's going to give us some kind of number that has no pattern. On our calculator, it may stop. It may look like it ends. However, it is one of those that doesn't have a true ending. The calculator will stop when it has no more room, but it can go on forever. So that's a non-perfect square. Pi, we've already talked about. Well, rational numbers are any numbers that can be written as a fraction. These could be in any of those categories. So rational numbers is kind of the big overhead category. So I could have a negative number. This is 10/3 is improper, but it's written as a fraction. It can be negative. We also have an 8, obviously just a whole number. It could also be a natural number, and it could also be an integer, but it's ultimately a rational number. Just like we're humans, that's how we can classify ourselves, and then we can classify ourselves further as a female, then down to a certain age category and so forth, race, different things like that. So these are more categories, but overall, we're all humans. So overall, this is a rational number. You can see 1/3. If I wrote 1/3 as a decimal, it's 0.33333. It's repeating, but it has a pattern. So that's why it's still a rational number. It's knowing what it's doing. It has some kind of sense about it. 0.25 can be written as a fraction, 1/4. So our next level goes down into integers. Integers are just, remember, those numbers that are positives and their opposites. So -3, +3, and it does include 0. Then we go down further to whole numbers. As you can see, it's kind of getting smaller. Whole numbers do not have any negatives, but does still include zeros. And then the whole numbers. They can be written as fractions because we can write a 1 as 1/1, still 1. We can write a 2 as 2/1. It's still a fraction. It's still 2. Then we get down to natural numbers. Remember, those are natural numbers. They can still be written as fractions, but they do not include 0. Now let's try a couple of things that are not rational. Now, so inside of your real number system, you have real numbers, and then outside of the system, you have non-real numbers. You won't really deal with non-real numbers as far as computation, but you need to be able to recognize and classify them. So if I look at the first one here, it looks like an I, this kind of a little cursive I. This is an imaginary number. You'll see those, and you actually get these when you deal with things that are like square roots with a negative inside or underneath the radical symbol. These imaginary numbers are not real. They would sit outside the universe, kind of like in outer space. We're the real world, and they would be in outer space. A square root sign can be a real number if it doesn't have the negative there. The negative makes it non-real. So if it's a negative inside, it is not real. Okay, we can have negatives outside, and we'll talk about that in a minute, but inside the radical symbol, we cannot have a real number. Any number that is divided by 0, obviously if we put that in our calculator, 3 divided by 0, we're going to get an error. We can never divide by 0. That is a non-real number. Infinity is a non-real number. We don't know the value of that, so that's a non-real number. These non-real numbers never fit on a number line. There's nowhere to put them because we don't know what their total value is. That's why they're not real. They cannot fit on a number line. So let's try a few. So we're going to just identify if these are rational or irrational. So our thought is, can we write them as a fraction? And if we can, what is that? So if I look at this number as 0.8, that's the same thing as 8/10. Well, immediately, 8/10 is written as a fraction, 8/10. Or we can simplify it down to 4/5. So it can be written as a fraction. So if it can be written as a fraction, it's rational. 0.333 and those dots mean it's repeating. So this 0.333, if we know our benchmark fractions, this is the same thing as 1/3. Well, if you put this in a calculator and you use your little calculator or Desmos and you 0.333 and you hit the little button, change it to a fraction, you'll see it'll give you 1/3. Or if you put in 1 divided by 3 into a calculator, it'll give you 0.3333. So it can be written as a fraction. It is rational. 0 divided by 6. Well, 0 divided by anything is going to be 0. So this is the same thing as 0. Well, 0 can be written as a fraction, 0/0, still 0. And we know that it's ending. It's not a natural number, but it's a whole number. It's an integer, and it is rational. So this is a rational number. On D, we see 0.1782334 and then ... We don't know what's continuing on with that ... There's no line above that's telling us that there's a pattern. So we have to assume that that's just going on, some randomness. We don't know how it's going to continue. So we have to think, we wouldn't know how to write that as a fraction because we don't know the rest of it. It's just kind of going on and on. It's being crazy. So this is an irrational, and you can abbreviate it as IRR. Then we look at an E, and we see 0.34, 34, 34, and there's a line right above the number. That tells us that 34 keeps repeating. We know it goes on forever and ever, but it has a pattern. So that is rational. Now, we have a square root symbol, and we have the number 2 under it. Well, you've got to remember what your perfect squares are. Perfect squares are those numbers that when you multiply it by itself, it can get a whole number. So, for example, if I had 2 times 2, that gives me 4. So the square root of 4 is actually 2. Well, there's nothing times itself that will give me 2. 1 times 1 is 1. 2 times 2 is 4. There's no other number in between there. So the numbers in between there will be decimal numbers that go on forever. So if you were to put this in your calculator, you're going to see that this repeats. So this is irrational. Now, on the opposite spectrum of the square root of 36, 36 is a perfect square. What number times itself will give me 36? Well, 6 times 6. So I know that the square root of 36, which is the opposite of something being squared, is 6. And 6 can be written as a fraction, 6 over 1. And we know if it can be written as a fraction, it is rational. All right, let's go a little further and let's talk about classifying them as a total amount. So you'll see I have a little table here, non-real, real. So this is where we're getting into, is it even real? If it's not real, that's as far as we have to go. It's not real. It doesn't fall in any other category. So if you have something in this category, it cannot be in any other categories. If you have something in the real category, then you have to go further and tell me if it's rational or irrational. If you hit irrational first, you're done. If you have rational, can it also be classified as an integer? Can it also be classified as a whole number? Can it also be classified as a natural number? So let's look at 3.4. So 3.4 is a number. We can think about it. Can I write that as a fraction? Does it make sense? Is it something like an I or a negative square root or something divided by 0? Well, so I know it's real. So I'm going to put a little check there. I know it's real. So then I think, can I write it as a fraction? Well, 3.4 is the same thing as 3 and 4/10, which then I could change to 34/10. And I could then simplify down if I wanted to, but it can be written as a fraction, so it is rational. Now, if I think about it as an integer, can I write that as an integer? Remember, integers are whole numbers and their opposites, including 0. Well, there's no way to get this down. If 10 into 34 gets me back to 3 and 4/10, that is not an integer. So it cannot be an integer, it cannot be a whole number, cannot be a natural. If it's an integer, or if it can't be an integer, there's no way it could be a whole number or natural. It has to fit into each category. So we know that this is a real rational number. That's how we could classify it. Now let's look at square root of 49. The square root of 49 is a perfect square, 7 times 7, so we know it's a real number. Is it rational? Well, it breaks down to 7. Can we write it as a fraction? Well, yeah, 7 over 1, so it's rational, which means it can't be irrational, so there's no reason to put anything there. Well, then let's go further. Is 7 an integer? Yeah, 7's an integer. Is 7 a whole number? Yes, it's a whole number. Is it also a natural number? It's a counting number. 1, 2, 3, 4, 5, 6, 7. Yes, it is. So we would classify it as a real, rational, integer, whole, and natural number. It fits into all those categories. Now let's look at the square root of 49, but now it has a negative in front. So what that means, that simplifies down, square root of 49 is actually a 7, and then the negative is applied. So we're talking about the number negative 7. Well, negative 7 is a real number. We've used that before in life. Is it rational? Can it be written as a fraction? Well, negative 7 over 1. Yes, it can be written as a fraction. As long as it's rational, it cannot be irrational. So we're not going to worry about that. If he's making sense, he can't not make sense. So now we're going to go, is it an integer? Well, is it a number or its opposite? Well, negative 7 is the opposite. So yes, it's an integer. Is it a whole number? Well, whole numbers have to be positive, and this is a negative number. So it can't be whole, which means it can't be natural. So we know that this is a real, rational integer. Now, the next one, we have the square root of a negative 49, and it's under the radical. Remember, any numbers that have a negative underneath the radical cannot be real. This is a non-real number. This would actually give us an imaginary number. So it's a not real number. We have no other worries about what classifies because it's not real. Now, 4 divided by 0. Anything 4 divided by 0, can we do that? Can we divide something by 0? No. That is a not real number. That's going to give us an error in a calculator. Now, on the next one, we have 0 divided by a negative 4. Well, if I take 0 and divide it by anything, I'm just getting a 0. Well, 0 is a real number. Is it rational? Can we write it as a decimal? Well, let's think about it. Fraction, 0 divided by 0, it's still a fraction. It looks kind of weird, we wouldn't do that, but it is rational. If it's rational, it can't be irrational. So then we can go to, is it an integer? Well, 0 is included in the integer. Is it a whole number? 0 is included in the whole number. Is it a natural number? No, because 0 is not included in the natural number. All right, you're going to have some practice and a few games to play to practice classifying. Do your best and come back to your notes if you need to.